Spider-Man, Spider-Man does whatever a spider can. Spins a web any size, catches thieves just like flies. Look out!
All right, welcome
Here
back.
comes the Spider-Man.
Solving projects by factoring. So part of this is that I assume you've learned this before in Algebra 1, which you have. You may have forgotten, but we also do these every day, as warm-ups, and they're in a lot of our problems as we go throughout the year. So this should be something that you've already know how to do, but maybe to a little bit harder level. All right, so the very first thing I want to get to is, let's remember what we have when we have two polynomials and we multiply. Remember, I take 2x, I'm going to multiply it by everything over here. I'm going to double distribute that. So 2x times x is 2x squared. 2x times 4 is 8x. Then I'm going to double distribute this negative 3. So negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. Combine these like terms, and we get 2x squared plus 5x minus 12. So what I want you to notice is that factoring, I'm going to do the opposite. So when I factor, I'm actually going to get this answer. All right. When I multiply, I get this final answer that could be factored, but when I factor it, I go backwards, like multiplying and dividing. They are, inverses. Okay. All right, so the method I'm going to teach you a really long way how to do it first. Well, it's actually not really long. It's not. But then I'm going to show you some ways to shortcut it as we go. All right. So the very first thing is I need to know two numbers that multiply to this times this. So I need to multiply to a times c. Remember, it's ax squared plus bx plus c. So I need two numbers that multiply to a times c. So in this case, a times c is 2 times negative 12 or negative 24. So I need two factors that multiply to negative 4 and at the same exact time add to the middle term, the b term. So we want them to add to 5. So I need two numbers that multiply to negative 24 and add to 5. So let's take a look. I'm going to draw a line here. This is called the Australian method, all right? Now I know in the end I'm going to have two groups here. I'm going to take my first term, the coefficient, and I'm going to put it in the front of both. Now I know x times x is x squared. That one's pretty easy to do. And I also know that 2 times 2 is 4, which is dead wrong. In fact, it's a whole factor more of that. I'm going to, in the end, need to divide by 2 because it is twice as much. It's an extra factor. I wrote this one too many times. So in the end, I'm going to divide by it. All right? So now I have to look. What are my two numbers that multiply to negative 24 and add to 5? If you're not good at this, you could write down factors of 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. And remember, since this is negative and it adds to a positive, we need one of these factors to be a negative. So negative 1 and 24 is 23. Negative 2 and 12 is positive 10. Negative 3 and 8, there we go. That's positive 5. So it doesn't matter which directions they go, negative 3 and positive 8. It makes no difference. All right? So now I'm going to go down to my next step here. And I'm going to look in this here. Is there any common factor that I can take out? Well, between 2 and 3, there's no common factor, so I'm going to leave it. Is there any common factor between 2 and 8? Yes, there is. I'm going to take a 2 out. So then when I take that out, 2x divided by 2 is x. 8 divided by 2 is 4. All right, and then down under, that's why they call it the Australian method, we have this 2. And now you can see we got rid of this extra factor of 2 right there. So when we have it, we have 2x minus 3 times x plus 4. And that is factored. All right? Now, what a great thing you should always do is I do a quick check, just a real quick check. First times first. 2 times 1 is 2x squared, perfect. Negative 3 times 4 is negative 12, perfect. If you aren't doing that and you turn it in and it's wrong, it's really foolish. I'm not saying that this is going to give you 100% accuracy, all right, because this middle term could be different, but it is a great start to it. It's going to catch about 95% of your mistakes, all right? So let's try example number 1. So I know I'm going to end up here. I'm going to put my first term here, g and g. Now, my term that I would go on the bottom is a 1, right? Because I have an extra factor of 1, but that's kind of stupid because 1 really doesn't have an extra factor. 1 times anything doesn't change. So let's take a look here. I need two numbers that multiply to 1 times negative 40. So I need two numbers that multiply to negative 40 and add to 3. What are two numbers that multiply to negative 40 and add to 3? So that's going to be positive 8 and negative 5. And again, there's no common factor to take out here. No common factor. So this is our answer. G plus 8 and G minus 5. Now you can check it out. It's pretty easy when it's a common factor or a leading coefficient here of 1. There's nothing to get rid of in the end, is there? All right, but let's check. G and G is G squared. 8 times negative 5 is negative 40. We should be pretty well off. Let's try number 2 here. So I'm going to multiply 5 times negative 4. I need two numbers that multiply to negative 20 and add to negative 8. Now I'm going to start this off by putting the 5x in the front of both. Okay. Now I know in the end I'm going to get rid of this 5. Now if you want, here's how we do it. Put that 5 here in the bottom so we know we get rid of it. All right, so what are two numbers that multiply to negative 20 and add to negative 10? Well, let's see. Negative 10 times positive 2 equals negative 20, right? All right, so let's check this out. So, common factor here? Yes, there is. So I'm going to take that 5 out. So now this is x minus 2. Common factor between 5 and 2? No, there's not. So that's just going to be 5x plus 2. And then these cancel. So we have x minus 2 times 5x plus 2. Let's check it. X times x is 5x squared. Last, negative 2 times 2 is negative 4. So that is pretty sure that's a great way to check it. Now, you could multiply it all out to check it for real, but I'm just giving you that's a quick check. All right, I know how some of you guys are. You don't like to check it all. So I think if I can give you a quick check, that's probably a little bit better. All right, let's check this one out. I need two numbers that multiply to multiply to 100 and add to negative 20. Now, if you are not good at figuring this part out, all right, you are just not good at finding the factors. At the end of this video, there is a calculator trick, all right? And the calculator trick will give you the table of all the numbers that multiply, okay? Watch that trick at the end of this video. All right. Meanwhile, we know right here, x times x is going to be x squared, so we're going to put those here. And what are two numbers that multiply to 100 and add to negative 10? Well, in fact, it's the same two numbers, negative 10 and negative 10. Let's check it out. Negative 10 times negative 10 is 100. Negative 10 plus negative 10 is negative 20. We're very good right there. Now, this one is kind of special because anytime you have the same factor twice, you can also write this as x minus 10 squared, right? Writing the same thing twice. All right, let's go on to this one. Ooh, this looks real tough. First times last, that is two numbers that multiply to 72, and then they need to add to 17. All right, so here we go. Now I'm going to show you this shortcut. It's really, really not that big a deal. 6p. So I know I'm going to get the 6p gone sooner or later. I'm not going to put it over 6. That's the shortcut. Shock. All right. So here we go. Two numbers that multiply to 72 and add to 17. Well, I know that 8 times 9 is 72, and it adds to 17. We still need to know, because I know I have an extra factor here. 6 and 6 is 36. It's not good yet. So I look here. Is there any common factor between 6p and 8? Yeah, I can take a factor of 2 out of there. Now, I put it up here because I know that I'm taking it out and I'm getting rid of it. Just like we got rid of it up here in the end. Now, I'm making a shortcut. This step I'm not actually going to write out. I'm just doing it, all right? 6 and 9, I know there's a factor of 3, so I'm going to get rid of that one as well. So now I come down here. 6 divided by 2 is 3p. 8 divided by 2 is 4, so we took our common factor out and we got rid of it. 6 divided by 3 is 2p. 9 divided by 3 is 3. So 3p plus 4 times 2p plus 3. You can check. 3 times 2 is 6p squared. 4 times 3 is 12. All right? And just imagine if we wrote, we would have had a 6 on the bottom. This 2 and this 3 would have been on the outside. 2 times 3 is 6, and it would have canceled. I didn't do that. I just wrote that down as a shortcut right there. Okay? Hopefully that works for you. All right, now we're going to use factoring to solve equations. All right, there's a huge difference between when I say solve and when I say factor. And oftentimes kids have problems understanding the difference. And if they put the wrong thing up there, I think you need to understand that it's not the correct answer. If I say factor, you're going to list things that multiply, factors. All right. If I say solve, you're going to tell me what x equals, all right, or y equals, or whatever our variable is. We're going to use this zero product property, all right? So the zero product property says this: if I have two things, A and B, and I multiply them and it equals 0, then A has to be 0 or B has to be 0. Think about it this way. Let's say I have 3 times x equals 0. I have one thing I know for sure and another one. The only possible factor here that would allow this to be true is if x is 0, because 3 times 0 is 0. So what we're going to do here is we're going to factor, and then we're going to set our factors equal to 0 using this zero product property, all right? All right, so let's do this. So the first thing we have to do is we have to make sure our squared term is positive. Now, I know it'd be easy to move our linear term, our y, over to this side, but it's unnecessary here that we move the y squared over here, and thus we have to move the constant over here as well. So now we have y squared, and make sure you put these in order. Y squared plus 3y, so we have our squared term, our linear term, and then our constant. All right, now we need a factor, so we need two numbers that multiply to negative 28 and add to 3. So if we factor that, I know that 7 times 4 is 28, and I know that 7 and negative 4 is negative 28. All right, and 7 plus negative 4 is positive 3. So now I have two things that could possibly equal 0. So I'm going to do the first one, y plus 7 equals 0. I'm going to do the next one, y minus 4 equals 0. It could be either one of these two answers. So the opposite of add 7, I would subtract, and the first answer would be negative 7. That's a possibility. Add 4, y could be 4. Now, these are simple ones. I understand that. A lot of you are just going to say this. A lot of you want to skip the step. You're going to say, all right, I know the two numbers that multiply to 3, or multiply to negative 28 and add to 3 are 7 and negative 4, so boom, I'm just going to switch it negative 7 and 4. But as we keep going here, imagine, we're going to get some harder ones that you just can't automatically assume you know what you're doing. You have to actually solve those, all right? Now we're going to sketch it, and here's why we're going to sketch it. You need to understand that these are solutions, and what are these solutions, okay? So now, when I talk about solving, these are called the roots, all right? Or they are called the zeros. And they're called the zeros because it is when y is 0, when our dependent variable is 0. So it's going to be, it is our x-intercepts. Where does it cross the x-axis, all right? So negative 7, 3, 4, 5, 6, 7. Negative 7, that's 1, and 4, 1, 2, 3, 4. Now, this is just a rough sketch. Remember from earlier in the unit, squareds are parabolas, and since I solved it so that it's positive, I'm going to make it go up. All right? Now, here's a trick. Later on in the chapter, you'll understand. We'll do this, and maybe we can have this negative, all right? And then we'll factor out a negative, and it could possibly go upside down as well. But you'll notice that this never changes. The roots, or the zeros, the solutions, when we solve it, are always going to be at negative 7 and 4. All right? So let's try this one. Let's solve it first. So I need to get this 7x to the other side. So 15x squared plus 7x minus 2 equals 0. So I need two numbers that multiply to 15 times negative 2, negative 30, and add to 7. All right, here we go. So I'm going to put 15x in the front of both factors, even though I know that's wrong. Okay? All right, here we go. Two numbers that multiply to negative 30. Let's see, 10 and negative 3. 10 times negative 3 is negative 30. 10 plus negative 3 is 7. I'm going to look here. Is there a common factor? Yeah, there's a common factor of 5. Here, between 15 and 3, there's a common factor of 3. So now I divide it out. 15 divided by 5 is 3x. 10 divided by 5 is 2. 15 divided by 3 is 5x. 3 divided by 3 is 1. All right. Now I have to use the zero product property and solve these. So 3x plus 2 equals 0. Or 5x minus 1 equals 0. Subtract 2, I get 3x equals negative 2. Divide by 3, and I get x equals negative 2/3. That's a possibility. Add 1, I get 5x equals 1. Divide by 5, I get x equals 1/5. So there are our two possible answers. Our roots, so if we sketch this, let's say we have 1 here, and negative 1 here, right? 1/5 is going to be about right here. Negative 2/3 is going to be about right here. And then we have a U. Almost made it right there. All right. Let's try this one. Find the zeros in sketch. So now this is find the zeros. It's the exact same thing. So f of x is 0. Because remember, when y is 0, that is our x-axis. So 0 equals x squared minus 4x minus 32. So let's factor that. We need two numbers that multiply to negative 32 and add to negative 4. Well, that's negative 8 and positive 4. Those are not our zeros. Those are not our roots. Those are not our solutions. We have to actually use the zero product property. 0 equals x minus 8 or 0 equals x plus 4. Add 8, x equals 8. Subtract 4, x equals negative 4. Those are our roots, our zeros. So let's sketch it. 1, 2, 3, 4, 5, 6, 7, 8. And negative 4. 1, 2, 3, 4. Let's see if Sullivan can do better on this one. Yes, boom. There we have it. All right, so let's talk about this in relationship to what we already know. All right, so let's find the zeros. That means we have to factor this. Two numbers that multiply to negative 8 and add to negative 2. So that's going to be negative 4 and positive 2. Now, a lot of you get this. This is going to be the opposite of this, x minus 4 equals 0, so x is going to be 4. And some of these are pretty easy. You could just write x equals negative 2. I see that as well, okay? Now, all I'm saying is this. You need to be careful, okay? You need to be careful because sometimes they're not that easy, and you guys just write down these answers. All right, so let's plot the zeros. So 4, 1, 2, 3, 4 is here, and then negative 2 is here. All right. Let's find the axis of symmetry. So remember, that's an x equation, and it's negative b over 2a. Negative of negative 2 is going to be a positive 2. 2 times 1 is 2. So our equation is x equals 1. So let's draw that line as best we can. X equals 1. Very nice. All right, find the vertex. So remember, I'm going to plug that into my equation. So it's going to be y equals 1 squared minus 2 times 1 minus 8. So this is going to be 1 minus 2 minus 8. 1 minus 2 is negative 1 minus 8 is negative 9. So 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9 down. All right. Let's take a look here. We can graph this, right? Over 1, up 1. Over 1, up 1, 2, 3. Over 1 up, 1, 2, 3, 4, 5. And it works out. Aren't we lucky? And then you're going to do a better job than I am because I am absolutely terrible at drawing these. And I almost got through all the points, but not quite. All right. So pause the video. You try these all on your own. So here you go. Check your answers. Over here we had 9h plus 18 equals 9h minus 5. 18 times negative 5. All right. And then we took out a common factor of 9. Over here I had to get the h squared to be positive, so I added both h squared and subtracted 3h. So then I factored, and I got 9 and negative 6. So here's a quick video of the boys from Big Bang Theory talking about Spider-Man. And then remember, if you want a great calculator trick for how to find what two numbers multiply to negative 30 and add a negative 13, for example, then stay tuned after that and you will see what you can do. I will see you on the flip side. Peace. Whoa, 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 whoa. Let's stop right there before we move any further, because see, here's the deal. Solon made a mistake. Just like you guys, I make mistakes, and I could easily go back and fix this in the video and you would never have known. But I think it's good for you to see that we make mistakes too. Two numbers that multiply to negative 90 and add to negative 13, that's negative 18 and positive 5. But what did I put? Positive 18 and negative 5. That clearly would add to positive 13. So this would be wrong. All right? This would be positive, this would be minus. So our real answer should be h minus 2, 9h plus 5. All right, so sorry about that. Hopefully you guys were realizing that that was my mistake and you recognize that instead of just blindly copying what we were doing there. All right, again, I would stay a little bit later and watch the trick for this on the calculator. It's a great trick so you don't make mistakes like I just did right there. Good luck. See you on the flip side.
Is anyone else troubled by the Spider-Man theme song?
Why would it trouble you? It's like your third favorite cartoon theme song.
It is. Right behind do-do-do-do-do, Inspector Gadget, and Teenage Mutant Ninja Turtles, Heroes in a Half Shell, Turtle Power. However, the Spider-Man lyrics posit that Spider-Man does whatever a spider can.
Yeah, so?
I can think of many things Spider-Man can't do that a spider can. 1, crawl in your ear and die. 2, legally leave Guatemala without a passport.
All right, so here's the deal. I learned this trick and I want to show it to you because I think it's going to help you. I think the number one problem most of you have is figuring out what two numbers multiplied in this number and add to the middle number. That's my biggest problem. You guys aren't good at your facts. And hey, that's okay. It's my job to find ways to help you. So I found a way. Don't tell Bean, don't tell Bruss, don't tell Kelly. All right? It's our secret. So here's the deal. You go to your graphing calculator, you go to y equals. When you get to y equals, you take the number that you want to multiply and you put it in, negative 40 in this case, and then you divide by x. Don't worry about the number you're adding to. Take the number you want to multiply to and divide it by x. Now I'm going to go to a table here, so I have to press second table. What this does is it gives me a list of all the pairs of numbers that multiply to negative 40. So check it out. 1 times negative 40 is negative 40. Now I have all the factors listed out for me perfectly. Now all I have to do is figure out which one of these adds to 3. So I'm going to go down. 2 plus negative 20 is negative 18. See, this one doesn't work. It's a decimal. 4 plus negative 10 is negative 6. 5 plus negative 8 is negative 3. All right, now, if you're good, you know right there that it's going to be switched, but let's pretend we're not good. We're going to keep going down our list. 7, no, 8. 8 and negative 5. 8 plus negative 5 is positive 3. Bam, you're done. You now know that the numbers that multiply to negative 40 and add to 3 are 8 and negative 5. All right, again, only put in the number that you want to multiply to. Then you go to second table, which is this graph button, and you find the list
that adds up to the other number. All right? Now, don't tell anybody. That's just our secret. Go.